Application of systems of linear equation. Given the sum of the two integers is 5. If their difference is 3, find the two integers. So we're looking for the two integers, and since it is unknown, we will use a variable to represent an unknown. So let x is equal to the first integer and let y is equal to the second integer. Next is we're going to set up an equation. That is by translating this verbal phrase into mathematical phrase. It means we need to recall our skills in our last year's math lesson in translation. So this sum here is translated as plus. Then two integers. So we represented x and y for that unknown integers. Then this word is translated as equals. Then the number 5. So that is now our first equation. X plus y is equal to 5 from our first sentence. So that's our equation 1. For our equation 2, their difference is 3. So that the word there, we are referring to the same integers, which is represented by x and y variables. Then this difference is translated as minus. The word is translated as equals, then number 3. And we have already our second equation, and that is x minus y equals 3. Okay, so the third step is we're going to decide which method are we going to use to solve this system of these two linear equations. So it is best to use an elimination method. So by adding these two equations, x plus x, that is 2x, positive y minus y, that is 0, then 5 plus 3 is 8. So then we want to isolate x, so we can divide both sides by 2, so that x is left and 8 divided by 2 is 4. Now after finding the x, we will now find y. We can use any of these two equations. So I decided to use equation 1, which is x plus y is equal to 5. Then replace this x by 4. Then it becomes 4 plus y equals 5. Then to isolate y, minus 4 to both sides, and y is left. 5 minus 4 is 1. Therefore, the two integers are 4 and 1. So by checking, so in our first sentence, the sum of the two integers is 5. Let's add 4 plus 1. So it is 5. So it satisfies to our first equation. How about in our second equation? Their difference is 3. So let's try to subtract 4 and 3. 4 minus 1 is 3. So it satisfies also to our second equation. Therefore, the two integers that we are looking for are 4 and 1. For the given number 2, 6 burgers and 5 fries cost 56 reals, while 4 burgers and 1 fries cost 28 reals. How much is the cost of each burgers and fries? So first, we're going to let B as the cost of each burger. So let us use the variable f to represent the cost of each fries. So the second step here is to set up an equation. So since this burger, we represent this by B, then end is translated as plus. Then we have here fries, that is represented by letter F. Then cost, we can use this, or we can translate this as equals, then 56. And this will be our first equation. So we can write here 6 from here. Then we can also write this 5 as well. So that will be our equation 1. So 6b plus 5f equals 56. That's how easy. Then our second equation can be taken from here. 4 burgers and 1 fry. So this burger is represented by B. So let us now write the 4. And here for plus. Then 1 and fries for F. Cost for equals. Then 28. So we don't need to write it anymore. So that is 4b plus 1f equals 28. So that will be our second equation. Now, the third step is let us decide which method are we going to use. So I think for me it is easier to use the elimination method. So let us first write the equation 1, which is 6b plus 5f equals 56. Then the second equation, 4b plus f equals 28. So as we notice, if we're going to add or subtract these two equations, we cannot eliminate one of the variables. So we're going to modify this second equation by multiplying negative 5 to both sides. Look what will happen if we're going to multiply both sides by 5. So it becomes like that. Why? Negative 5 times 4b, that is negative 20b. Negative 5 times 5f, it becomes negative 5f. Then negative 5 times 28, that's negative 40. If we're going to write down the equation 2, you can see positive 5f and negative 5f can be cancelled now. So we will be left with b. So that's the very reason why we multiplied negative 5 to each side of equation 2. Okay, so next, we can now eliminate 5f and negative f. So we will be left by 6 minus 20, that is negative 14b. Then in here, 56 minus 40, that is negative 84. So you want to isolate b, divide both sides by negative 14, so that b is left, and 84, or negative 84 divided by negative 14, that is positive 6. Now, to find f, we can use any of these two equations, but I prefer to use equation 2. Then replace this b with 6. Then 4 times 6 is 24. Then add negative 24 to both sides so that f is left. And 28 minus 24 is 4. Therefore, this b, which represents the burger, and this f represents the cost of the fries. So our answer is the cost of each burger and fries are 6 reals and 4 reals respectively. So that is 6 reals for burger and 4 reals for each fries. Now for checking, if you want to know if our answer is really correct, so we can try to substitute this in these two equations if it will satisfy. Since the burger costs 6 and the fries costs 4, let's try. 6 times 6 is 36. 5 times 4 is 20. So 36 plus 20, it makes 56. So it satisfies our equation 1. How about in equation 2? Since b is 6, 4 times 6 is 24, plus the f is 4. So 24 plus 4, it makes 28. So it also satisfies our second equation. Therefore, this one is correct.